Friends, today we will learn type of rectifiers. Rectifiers. One is half wave and another is full wave. In full wave we have two more configuration. One is center tap rectifier, other is bridge rectifier. In half wave you only need an AC source and then one diode, and this diode connects to the load, whatever load you have. That could be a lamp, motor or whatever, and here you can connect one capacitor to minimize the ripples of AC. This one is the plus and this one is the minus, and same is here. And in center type rectifier you need a transformer having one primary coil in which the AC will be input. Here this is the input AC and this is the DC. Output will be DC with half wave. Half wave. And the output will be, let's assume the input is, and then the output will be only half cycle, then there is no voltage. This will be the output, only half wave will come. The output will be like this only, of half wave. And in this center type rectifier we need a transformer. This is the primary coil, primary, this is called secondary, in the center we will tap one. This could be any voltage. For example, let's assume this one is 12, 0 and 12, and the rectifier will, like, this will be one diode, this will be grounded, or you can say earth, this is another diode, and these two will get joint, and this is another capacitor to minimize the ripples of the AC. And this will be their output. Load, this could be anything, this could be a DC motor or an LED or any lamp where you need a DC voltage. The output here will be, there will be two different AC cycles. One is in this and another is this. Once we have high this side, and that at that time there will be low this side. Half cycle of the AC will be this side and the half of the other side. And again when there will be high this side, and there will be lower side of this side, and the output will be, let's assume this is the input and the this will be the output of rectifier. And after using the capacitor, the output will be almost this. There will be some pulsated DC. And in bridge rectifier you don't need any transformer, only you need an AC source. Bridge rectifier is, this is your negative and this is your positive, and this is the AC input. This could be anything, and here you can also connect one capacitor to minimize the pulse ripple of the AC. And in this case the input will be, this is the input and the output will be, and after using the capacitor the output will be. Now we will make same thing in practical. Let's go. Friends, first we will make half wave rectifier. For that I have taken one diode which is IN4007, commonly available, and I will connect positive side of this capacitor. This capacitor is 63 volt and of 10 microfarad. And this will be the negative side. In this LED will be our load, and we will connect positive to this terminal. And this capacitor has desoldered from the location. We have to resolder it. Friends, here I will connect 230 volt AC input. Yes, I have connected the AC input, and I need to first insulate it. Friends, I have switched on the supply. You can see how it is working, and due to high voltage I have to insert one resistor to drop the voltage. Friends, I have connected an LED as a load with half wave rectifier. The flickering you are seeing in this video is due to half wave. If there will be a full wave rectifier, the flickering will be less. So I will show you the full wave center type next. For making it full bridge center type, I will use the second coil and connect it to the positive of the load. And this is now our center type bridge rectifier, center wave full wave rectifier. This is the two legs and this one is the center tapping. And now let's supply it on. Now you can easily see the ripples or the flickering has all gone, because the voltage is now coming in full wave, not half wave. Now let's check the voltage, how much is coming in center tap and full wave, and how much is coming in half wave. Here is the multimeter which is now measuring the voltage. This is the AC voltage 23 from yellow to yellow. From yellow to black it's 12 and other yellow one is 12.54. Yeah, this is exactly the center tap. And what is the output of in DC? Let's measure it. This one is our negative and this is the output. Output is 10.5 volt. And how much this is resistor is dropping? We will check. 3.6. Yes, this resistor is dropping the voltage almost 6.87 volt. That means it is making this LED to sustain at this voltage. If we will again make it half rectifier, then we can see what happen. The flickering will start again. Yes, you can see the flickering because of the half wave. And now let's measure the voltage, how much voltage is coming. Because of the ripples, the voltage will be high. 6.6 is the voltage and 3.1 is the LED, the load is getting voltage. And if we connect again, the flickering will stop because now the pulse is, there is no half wave, this is the full wave. The full wave is coming. Now let's make bridge rectifier. Now we are making full bridge rectifier with no center tap. This is our output and this will be our input. Friends, we have made one bridge rectifier, and in this you can see 4 diodes and 1 capacitor and 1 load. This LED and this resistor is considered as a load. We will now check the voltage, how much AC is coming and how much DC it is getting produced. Initially the multimeters, this is 10.6, 10 volt, 10 volt it is generating, and 6.4 this resistor is getting drop, and 3.6 is in the LED. And let's see how much is the AC is coming. And this is a 12.6 volt AC is coming in the rectifier, and the same is being converted into DC by bridge rectifier. Now let's do one thing. Let's connect this AC directly and then see what voltage we get when we connect it to, when we measure it after the diodes get converted into DC.